Good afternoon and welcome to this afternoon's webinar from Safeguard Europe Limited, dealing with dampness in buildings. I hope you can hear us clearly. Now's the time to adjust your settings if you need to. Just to introduce ourselves, my name is Damien Wallace, Technical Manager at Safeguard, moderating the presentation while my colleague Michael Pryor from our laboratory will be presenting today's talk. Presentation should last about 45-50 minutes, and we have some time at the end as well for any questions. There is a link below in the description section of the YouTube channel to submit your questions if you have any. Hopefully you do. Okay, so that's probably enough from me, and I think what we'll do is perhaps just hand over to Michael for today's presentation. Thank you, Michael.
Okay, thank you, Damien. Yes, like I said, my name is Michael Pryor and I will be presenting this Safeguard webinar. This one is dealing with dampness in buildings. So just very briefly, just to say who Safeguard are. We're based in Horsham, West Sussex, been around since 1983, and we specialise in damp proofing, waterproofing and general sort of structural repair and timber preservation. We have quite a large technical support team, so we do research with a little R&D department with 4 chemists, and we've done collaborations with different universities such as University of Portsmouth. Some of the brands you'll be aware of, such as Dry Zone and Storm Dry, and they're sort of the ones that we'll be focusing on today in this sort of general overview of damp. So starting what we're going to be going through in this webinar, we'll be looking at sort of dampness in buildings. So what is dampness? We're looking at why you need to treat it, and actually the sort of correct identification of the different types of dampness. So in terms of what tools you need to use, and then what the actual treatments are for the damp. So just starting with what is dampness? So in a nutshell, all sort of building materials will contain some level of moisture. Even sort of building materials that you would term as dry, they will still have a little bit of moisture. So for instance, plaster, fully cured sort of sand cement plaster will have between 0.2 to about 1% moisture in there. And then that level is deemed that it's low enough that we could call it dry. It's only when you get above, say, about 5% in plaster that you would then start to think you have a damp problem. Sort of in contrast though, timber and sort of wood can actually naturally have about 15% moisture in there. So it's just always worth about keeping an eye about what these sort of normal amounts of moisture are sort of expected in your building materials. And that's, if there is a high level, you just got to see, is it higher than expected for you to have a damp problem. So where does dampness occur? It's mainly where moisture becomes visible or there starts to cause actual decay. So some of the actual signs you're going to see are discoloration and staining of your finishes, mold growth on the surfaces. So this is quite a bad, a really sort of extreme example, but this has happened before. A sulfate attack or frost damage, so where you get sort of freeze thaw in the brickwork when it's got wet and then frozen overnight, or from a salt attack. Drips or puddles, usually quite good signs of any moisture getting into a property. Deterioration caused to the building fabric, so we're looking at sort of timber decay such as dry rot or wet rot, or other things such as sort of like beetle attack. So what are the reasons for actually treating your dampness? Firstly is the actual practical side. So you want to, like say, rectify the problem sort of described on those previous slides. So you're looking at actually fixing these issues. And the other part is the sort of governmental. So as part of the building regulations, so Part C has a section about treating properties with dampness. And also there was the Homes Fitness for Human Habitation Act of 2018, and that essentially came out with guidelines about dampness. So just sticking on that Act from 2018, there were some guidelines and criteria that landlords now have to meet to be able to rent out their properties. And you can see there's a few options there, things such as repair and natural lighting, things like toilets and areas for food preparation. But the ones you can see underlined is freedom from damp. And essentially what that looks at is the idea that if there is damp in the property and the tenant makes you aware, the landlord aware of it, that they then must rectify it. And if they don't, then it can allow the tenant to take the landlord to court. And that is now active as a law now. So you can see here is for when you're doing extensive sort of remedial DPCs, there is actually a section here in the building regulations about the resistance to the passage of moisture from the ground to the inside of the building. So this is actually in there, so it must be rectified where it has been sort of spotted. So for dampness, there are sort of three main types that you want to be aware of. The first one is rising damp. Second one is penetrating damp. And the third one is condensation. So we'll look through all three in a general overview during this webinar. So when you are come to a property that does have some form of damp, the first thing you need to do is use some form of tools to diagnose the damp. So correct identification is very important because it then decides what treatment you're going to go down. So what are the main tools that you want to use? The first one is your sensors. So this is doing simple sort of surveying, external examination of the property. So you're looking at, you can see on this picture here, you're looking at sort of common defects in property. So things such as the external rainwater goods, so gutters and sort of runoff areas. Any sort of external timbers outside that could be allowing moisture in, air vents or air bricks, whether they're being blocked up or in correct positions, and then things for in terms of remedial DPCs that have been installed, maybe they've been bridged, and other areas such as sort of cracks or any sort of defective pointing and render and brickwork in the property. So these are things that you need to be looking out for when you're first assessing a property. And when I say obviously your sensors, the other things you'll be looking out for are those sort of your smell, and you're looking out for any sort of like odors in different areas as well. So you can see here when you're getting inside the property, you're looking for those first sort of incidences of damp. So you're looking for any like peeling or blistering paintwork, efflorescence coming through the plaster, and any sort of like musty smell or sort of fungal decay. So these are sort of signs that there is some form of damp, and you need to identify which one's associated with which type of damp. So one of the tools that quite a lot of you will be aware of is the moisture meter. So they're quite useful as an initial starter when you're trying to identify damp, because they're sort of a non-destructive on-site testing, so you can do the analysis there and then. And what you can do is you take different measurements along the wall. So the one in the pictures there is the Survey Master sort of protometer. And the idea is that it's got a few different modes, so you would use it depending on the situation for the different modes. The one thing you must be aware of is that they have their weaknesses. So they cannot be relied on to measure the actual moisture content. So they are calibrated for wood. So the measurement that you get is the percentage wood moisture equivalent. So just be aware of that. It's all sort of with sort of like a reference point. So they can give misleading readings if you have any sort of contaminated salts in there, so that'll give high readings, or any sort of foil back paper within the wall. So just be aware that they could give you misleading sort of high results. So just don't use it as your only way of checking for damp. But if you do use one of these moisture meters, these are sort of like profiles that you would get. So you can see on the top left there, that would be your sort of classic case of a rising damp situation, of a high moisture readings up to sort of a cut-off point where the damp is no longer rising. Whereas you've got a few examples here, and then you can see the one down on the far right, bottom right there, is sort of a case you would get for some form of condensation, where there's sort of a gradual decrease in moisture as you go up the wall. So you just need to look at what sort of profile you get and use these as a good sort of reference points. So like I said, there are the three main types of damp. So now we're going to look at the first one, which is condensation. So how does condensation form in buildings? So the key point when you're looking out for condensation is the idea that warm air contains more moisture than cold air. And it's the idea that as you get the air temperature cools, if it cools near a cold surface, then the air can no longer hold the moisture and will condense onto that cold surface. So it will reach the dew point in which the air is completely saturated, and any excess moisture is then deposited as liquid water onto the surface. So that's what you're seeing when you get sort of moisture appearing and like drips on your sort of glass because it's cold, or in sort of lower areas, sort of behind cupboards and stuff. So where does this actual moisture come from? So internally there's always more moisture within the air than outside, and this comes from very many sources, starting with sort of the people within the room. So we produce moisture from breathing or sweating or doing exercise, from cooking. So water vapor will be coming from your boiling of water for like pasta, and will be different depending on if you're doing like electric or gas. Bathing and washing. And drying of clothes will be a classic one in quite a lot of small rooms if you go to different properties. And the idea is that if you have two sort of people within a property, they will typically generate anywhere between about 9 to 12 litres a day of water vapour. And naturally there is approximately about 5 litres of moisture in the air. So by adding two people, you're effectively doubling the amount of moisture within the air. So by increasing the amount of people in a property, you're going to have more moisture being produced, and so you could have a more risk of condensation. So when you're looking to identify condensation, the things you want to be looking out for is sort of timing. So condensation normally occurs in the cooler months. So the condensation season, as it's known, is usually between about October and April. So that's when you're going to have sort of warm periods during the day and then a cooling period during the evening, which will allow any moisture to sort of condense onto these surfaces. You've got visual assessment, so water droplets on sort of impervious surfaces, so where you've got moisture on sort of tiles or windows. And mould growth, that's usually quite a common aspect of condensation. So this is where you'll get areas of poor airflow, so especially around sort of furniture and built-in cupboards. So if you remove those, you'd quite often find mould growing behind there because there's less movement of air. So thinking of those tools again, one that you can use for condensation is the digital hygrometers. So what these do is that they measure the water vapor in the air, so it can be quite useful when turning up on site. So here's one of the Hygromaster 2, which is quite useful by a protometer, and what it does is, like I say, it measures the amount of water vapor to help you identify whether you've got condensation as the issue. But be aware that these are only a snapshot measurement, so it sort of depends on what type of day you do the measurement. So you might want to do one in the morning, one at noon, and one in the evening to see if there is different times when the condensation might occur. But a more accurate way that can be used are data loggers. So these are little units that can be put into a property, and what they do is they take accurate continuous readings of the temperature and humidity in a property. And what you can get now are these sort of Bluetooth ones that you can actually access on your phone or on your laptop. And what you can do is you can look at these sort of graphs, and they can give you a moisture activity of a property. So you can see at what times of day the humidity, for instance, gets high or low, and that could tell you what could be the issues. So the formation of moisture itself may not necessarily be the problem actually in a property, because what happens is that any water that has evaporated then condensed on the surface will have a higher purity, so effectively it's been distilled of any sort of impurities from where it's come from, and this actually means that it's an ideal sort of situation for mold growth. So it's very common that you'd find in that picture in window seals and anywhere where they sort of collected, that mold will actually start to grow, and this is actually a very big concern to people's health. So what are you going to look to when you're dealing with condensation and mold growth? So one of the methods with dealing with condensation can be to use sort of like biocidal cleaners and paints. They're seen as sort of practical, simple solutions. So where you are in a situation where you have got a property that's suffering from condensation, but the homeowner doesn't have the budget to afford brand new insulation, or able to get new vents put in, as a short-term fix, what you can do is use a biocidal cleaner such as Dry Zone 100 to kill the mold that is currently present. You clean the surface off, and then for sort of future proofing for a good up to about 5 years, you can then apply some paints that contain active biocides in them. So Dry Zone mold resistant paint is a standard emulsion paint with added biocide, and the idea is that this is a sort of an economic way at preventing mold growth in the short term.
I think it's also a good starting point, regardless of whether you're a tenant, but also a homeowner or a landlord looking to, deal with the symptoms that cause people the most distress without having to spend a fortune. It's a good starting point, I think, isn't it, to then further understand what the problems are, why you're getting condensation in these areas.
Yeah, so it's a good way of sort of fixing someone's mold problem without having to go through the whole rigmarole of have them having to move out for a few days to for you to sort of install and sort of replaster the whole room. So it's a good sort of quick fix sort of solution. But in a situation where someone does have their own favourite paint they want to use, you can also have one of these biocidal additives. So these can be added to any type of paint at different levels, and they will be effective at preventing black mold on your paint surface. They can also be added to grouts as well for bathrooms. One of the other measures you can do at prevent condensation is reducing the amount of moisture being produced. So simple lifestyle changes to for the occupiers. So things such as removing gas heaters, making sure that tumble dryers are venting outdoors, and distributing their clothing. So when they're drying clothing, making sure they're doing it in different rooms. And simple measures such as taking shorter showers and cooking with lids on the pans. So these all can be found on documents by such companies such as the PCA, and also can be found on the NHS website as well. Dehumidifier is also a helpful way, but obviously they only deal with the symptoms, so they can have high running costs because you're not actually fixing the condensation, you're just getting rid of the moisture that's being produced. But they are good for short-term areas. So where you are in a situation where someone is able to put a fan in, improving the ventilation is always a great way of fixing condensation. So things that can be done is installing air bricks and trickle vents, and then the slightly more expensive but effective measure is installing humidistat fans and positive pressure units. So what you would do is you install these extractor fans, which would the new modern ones will actually turn on when a certain humidity is reached, and then look to lower the humidity to a safe level. So new building regulation requirements for buildings usually have them to be quite sealed, and so that actually reduces the options. So that is where you would need to have some form of mechanical ventilation as a measure of fixing condensation. So increasing air temperature is also a good way. So in cold weather, the best way to keep rooms warm enough to avoid condensation is to keep low background heating on all day. So the idea is that you don't want big swings in temperatures during the day. You want to keep a consistent medium temperature. So by doing that, you want to also look to increase the surface temperature. So this is actually looking at insulation. and actually even a small difference in the surface temperature can be enough to prevent condensation and mold forming. So you can see in that top picture is a property where you can actually see where the insulation hasn't been installed properly, where it's actually been missed out. You can see those little gaps in between the mold sort of bands there. So increasing the surface temperature can be done by a few ways. One is using sort of insulating panels such as ultratherm, and these are ways of these could be plastered onto and be used as the sort of final finish, as a way of sort of increasing that wall temperature. And sort of the slightly more expensive but modern, new way is using sort of insulating MgO aerogel boards, so things such as storm dry EP board. So these are a 10mm aerogel blanket which has a high insulating value, and that also has an MgO board on it, and so used correctly with storm dry externally, it can actually improve the U value of a solid wall by up to 60%. So it's quite an effective measure for small rooms where you don't want to lose floor space. So very good for those areas, so especially for sort of inner London or in loft spaces, or like say in small rooms. So that's basically looking at condensation there in general. So like I say, you're looking at treating the mold, increasing the ventilation, and increasing the sort of temperature of the room in the air and on the surface. Right, so now we move on to the second type of damp, which is penetrating damp. So what is penetrating damp? Essentially, it's the ingress of moisture through the walls into the internal structure. So where this is really problematic are on single skin walls, cavity walls, wall ties, and where any sort of insulation has been installed. So with the new sort of Green Homes grant around the corner, this will become a very important topic for anyone who is looking to be involved in that area.
I suppose that also a little segue there to our recent webinars, presentations to do with PAS 2035 as well.
Yes, so if you are want to become sort of trust marked or want to understand what the Green Homes grant is, I'd recommend getting in touch with Safeguard about the PAS 2035 webinar if you want to. So now we're just looking at diagnosing penetrating damp. So the key areas, again, coming back to this picture again, is sort of looking externally. So anywhere where there's sort of defective guttering or sort of flashing or chimneys, and anywhere where you've got deteriorating sort of brickwork, so where the render. So these are sort of like multiple routes where moisture can get in. It's very common, especially in older properties that aren't being maintained properly. And the idea is that you need to make good any repairs before doing any other sort of treatment internally. So what are the symptoms of penetrating damp? So you get damp patches on the wall, paint blistering, grinning mortar joints. That could be quite a common area, you can see that. Circular spotting or blotches, so instead of getting damp that's sort of at the bottom, which would be rising damp normally, is sort of appearing at higher areas throughout the wall.
I think also, sorry to interject, that's also potentially problems with things like wall ties, which might be bridging, and even having been in a few buildings where the option for covering up damp involves effectively dot and dab. Plasterboard onto problem walls, so if you tap the wall and there's a hollow sound behind it, quite possibly that someone's tried to cover up an issue by using plaster based bonding adhesive onto the wall to stick a board to it to cover it up, and obviously while there is dampness there, it will travel through the plaster adhesive and show us dampness on the inside wall. Is another issue that you get as well.
Yeah, so definitely if you do see sort of a small circular blotching, it can be a case of a plasterboard that's been incorrectly used, or as haven't used a water resistant adhesive to stick onto the wall. So that's what's with the symptoms. So now we're looking at the common causes of penetrating damp. So like I said earlier, blocked or leaking gutters can be one of them, but actually you may not know that is a problem until it's raining. So quite a common thing to do is when someone has got damp, it's quite good for them to say, if it is raining outside, go and have a look and see if any of their gutters are leaking over a certain wall, and that could be a reason why that certain section of wall is becoming wet. Defective pointing. So on fair-faced masonry, pointing will degrade over time. This can be caused by a few things, such as incorrect mortar being used, sort of acid rain, which can cause the sort of lime and sort of binder to sort of degrade over time, and sort of the wrong sort of actual finish as well. So for most situations, we would recommend sort of full repointing might be required, and then in terms of what finish, the best types are to use a bucket handle or a flush pointing, which offers the best rain resistance. We'd not recommend to use recessed, as that will allow pooling of moisture and also can allow sort of little hairline cracks to appear at the joints, which could allow moisture to get in. Defective flashings, so where the flashing has corroded or has been poorly installed or even just poorly detailed, this can allow moisture in, so this should either be replaced or fixed by a roofing specialist. Holes in walls, so this can be very common when, for instance, you have a brand new property which you shouldn't think there'd be holes, but then a brand new sort of satellite dish has been installed, and quite commonly they'll drill a hole in to fix their ladder to the wall, and then they don't fill the hole back in after they've left, and that can leave a gaping hole which allows moisture in. So these can be left by a sort of removal of any sort of fixings or pipe work that's been removed, and so these just simply need to be filled with a suitable sort of long-lasting mortar or sort of polymer. So that's a quite easy fix. Faulty windows and door seals. So most sort of seals around windows are made from sort of silicone, and depending on what type you use will depend on their sort of durability. Most recommendations is to use sort of UV resistant ones, so sort of MS polymer type window sealants, and essentially they need to be replaced sort of every sort of 10 years is when you're looking at sort of most common sealants. Porous brickwork, so for especially older properties, they could be built from sort of underfired bricks or sort of poorly conceived bricks, and over time, especially if the structure opens up and they become more porous, they can allow moisture in. So in these situations, the sort of treatment you're looking at is either sort of external waterproof repellent cream such as Storm Dry, or maybe some sort of like rendering onto the wall. So the idea, if you have this sort of porous brick, you can get a spalling. So this can be either from salts, so salts building up behind there and causing the front to blow off to spall, or possibly from freeze thaw. And if the this exposed face does appear, that will actually attract more moisture because it's far more porous. So when you're looking at penetrating damp, one of the key aspects are cavity walls. And effectively this little diagram here show that regardless of what type of insulation, moisture will find a way in. Even so, for foam fills, it will find sort of little voids that haven't been filled, sort of around the wall ties, for it to get into the internal leaf. When you get to particulate fills, you can find areas where there's sort of little drops for where water can fill in, and eventually it will bridge into the internal wall. And then fibre fills, quite a lot of the time, but if you're not correctly installed, there will be quite big voids, and these can then fill up with water and eventually make their way into the internal leaf. So what do you want to do when you have found penetrating damp is to treat it, and the most common sort of treating is to firstly repair and rectify any masonry defects. So you're looking at fixing any pointing or holes, and fixing any sort of brickwork that's become deteriorated as well. Any algae that might be present on the wall should be removed. This can be done by using a biocidal cleaner such as Roxol 100 wooden patio cleaner, and the idea is quite a good way of doing a sort of pre-treatment before applying something such as Storm Dry. Structural repairs, so using things such as helical bars to crack stitch any sort of large cracks that might be in the wall. Be aware that when you are in this situation, there might be some structural defects in the wall, so you might want to look at if there's any sort of movement within the wall. So that could be a cause of these sort of issues. Replace and repair any flashing, like we said earlier. That's quite a key thing to be done, and that should be done correctly and sort of done by a specialist. Filling any holes and voids, so you can use it. You can either fill it with a standard sort of mortar mix, or you could use these sort of ready-made mortar mixes such as Storm Dry XR mortar. So these can be easily sort of piped into the hole, and should be a sort of great little like patch repair tools. Repointing, so quite common. You should try and repoint with a similar type of mortar that's already there, and checking in terms of any frost the next day. So most common sort of mixed, as a sort of rule of thumb, is sort of like a 6-to-1 mix of sand, lime and cement, and that should sort of, as a rough sort of rule, should be good for most walls, but just check on site on what you're dealing with. Coatings. So very commonly these can be a very big issue, where impermeable paints have been applied to the wall and slowly they've blistered and they trap moisture behind them. Unfortunately these most commonly need to be removed with a paint stripper. That's what we would recommend here at Safeguard. And then if you have got, like say, any paint, make sure that you then replace it with a breathable paint, such as a moisture resistance or breathable paint, such as Storm Dry hybrid silicone paint. When you come up against any sort of defective render, traditionally renders being used to cover up any poor quality absorbent brickwork. But if a cement render's been used, quite commonly that can then shrink and cause cracking, and that will actually then trap moisture that gets in behind it. So it can be even worse if that render has also been painted with a impermeable paint. So some of the options basically is to either repair it or replace it with a more breathable render, so such as a sort of like K-Rend or a lime-based render as an alternative. And then one of the most easy ways to sort of fix penetrating damp is to treat any porous masonry. So if you have a unpainted and unrendered wall, is to use a masonry protection cream. So these are water repellent creams applied in single coat and sort of penetrate up to about 12 millimeters. They're clear coating, so they don't change the appearance of the wall, and should last up to 25 years. So Storm Dry, for instance, has been BBA approved, and are very useful for properties that have driving rain. So one of the actual benefits of using these repellent creams is the heat saving. So the idea is that wet walls are less thermally resistant than dry walls. So 35% of heat loss can be through the walls. But so by treating your masonry with Storm Dry, for instance, you can actually reduce heat loss by up to 29%, which was testing done by the University of Portsmouth. And this can be done without changing the original appearance of the brickwork. So really beneficial for sort of solid walls and single skinned walls. Okay, so that's penetrating damp sort of done. So we'll move on to the final type of dampness, which is rising damp. So what is rising damp? So basically what it is the vertical movement of water up through permeable wall structure using capillary action. So the idea is that masonry effectively acts like a wick, and as the water comes into contact with the in the ground comes into contact with the wall, it will slowly rise up through the pores, so the capillaries within the masonry, and then rise up through the wall. So this is mainly common in older properties or anywhere where there's a failed DPC. So how can you identify rising damp? Usually it's the visual signs, so a tide mark, a salt band, or a ground up moisture level. So as we said earlier about when you're doing those sort of moisture readings, you would have like high levels at the base level of the wall, which would slowly, which would then get a big old cut-off point around about, depending on the area, about up to a metre high. So here you can see there'll be high moisture readings with a sudden cut-off point, which is usually in line with the salt band. And you usually get those salt bands because that's where there's the evaporation, and so the salts then come to the surface. So what are the causes of rising damp? So one of them is the moisture in the ground actually contains ground salts. So these are your common ground salts such as sulfates, chlorides and nitrates, and what happens is these are soluble within the water, and as the moisture rises up, they bring the salts up with them, and as the moisture evaporates away, it then basically leaves the salts within the wall. So over time these salts will accumulate in walls that are badly affected by rising damp, and they will concentrate at a salt band at the maximum height of rise. So the main common ones are sort of like the chlorides and nitrates, and these are hygroscopic, which means they attract moisture from the surrounding environment. So even though you might install a brand new DPC, these salts will remain, and what happens is these salts can actually still attract moisture. So when you get a call back to a property where you think you've fixed the rising damp, what can happen is that the damp they're seeing is actually just a hygroscopic damp. So that's where you'd need to do some sort of form of special replastering to deal with these salts. So part of the reason for rising damp is either no DPC is present within the wall, or it's been broken and requires a remedial DPC. And the other one is where you might get a bridge DPC, where say for instance on the outside, the external wall, there might have been a new higher ground level been installed, and that has bridged the DPC, allowing moisture to rise up through the wall. Another one just to be aware of as well is impermeable coatings on the inside, so changing the amount of evaporation in the wall. So the balance between rising damp and evaporation is effectively a balance, and you want to allow as much evaporation through the walls as possible. So how do you treat rising damp? So one of the old methods was to effectively cover up the damp, so using sort of plaster membranes. But these need to be used, properly. So you need to make sure that it's been installed high enough so that the damp then doesn't just rise above it. The problem with using this technique is that it will reduce the evaporation, which will actually make the rising damp front rise higher. And also, if it's not done extensively, the damp can actually spread around the sides. And if you do this type of method, there will actually be no improvement in the thermal performance of the walls, and the moisture will still be present, and the ground salts will continue to accumulate in the wall.
So just for clarity, so that's more of an actual physical membrane as opposed to a render or a plaster, isn't it? That's
Yes.
Like the studded plastic membranes.
Yeah, so this
have a mesh on them.
Yeah, normally this is sort of the like I say, plastic membranes, which have been used for a while, but sort of you wouldn't recommend now for rising damp situations.
Not necessarily the product itself, but the way it can be misused rather than installed properly.
Yeah, so if it's not installed properly, you might not solve the actual damp itself.
Just as a quick reminder, if anybody has any questions, please feel free to submit them in the description link at the bottom.
So one way of treating damp is to use a physical DPC. So on new properties, a physical DPC has to be installed as part of the building regulations, but in older properties you can actually remedially install one. So one of the ways is to use effectively a chainsaw to cut through the mortar bed and install a physical DPC in sections. So this can be advantage is that you do actually get a guaranteed sort of continuous barrier, but effectively it's a very costly method and can take a lot of time and cause a lot of disturbance to the occupiers, and it can also if not installed correctly, can actually damage the structural integrity of the wall. So it is not usually recommended. So because of that, one of the most popular methods to deal with rising damp is to use a liquid chemical, chemical DPC. So these can be extremely effective. So they've been used around for about 50 or 60 years. So some of the old ones you can see in that picture was old style sort of siliconates. But the only problem is that the actual effectiveness of the treatment was sort of reliant either on the product quality, the quality of the installation, and the condition of the mortar course. So the issues that you could find in sort of in this old fashioned way now is that you could get insufficient dosing, blowback, or in especially situations where you've got cavity walls, essentially all you're doing there, you might just be filling the cavity with the liquid water repellent. So now it's seen as using pressure pumps is used as a sort of fairly old-fashioned route. So the new slightly more modern method now is using a damp proofing cream such as Dry Zone. So they were introduced in 2000 by Safeguard, which patented and developed it. And these are silane and siloxane based creams. So they're easy to install. They can be simply using a mastic gun, for instance, and they overcame the sort of lots of limitations of standard liquid injection DPC. So they're lower hazard and have higher actives content. So Dry Zone, for instance, has an active content of around 70%, and have the sort of same performance as a physical DPC. So Dry Zone, for instance, has been approved by the BBA, WTA, and a host of other organisations in Europe. And then in 2014, Dry Rod was launched by Safeguard, and this was sort of now the pinnacle of rising damp treatments. So these are effectively cotton fibre rods which are soaked in the active silane sort of active ingredient, and they guarantee a more consistent dose per hole. They're less messy, and you can then get a more clear idea of how much you put into the hole. So you get improved performance, and these are also been BBA approved and WTA approved. So these are seen as the best treatments for rising damp now.
The more accurate dosage.
Yes, that's it. So you can see there in that picture, you would know if you filled a hole correctly. Instead of sometimes with creams, you may not know how much of the hole you've actually filled. Even though you think you have filled it, there may be areas where it hasn't been fully filled.
Right, especially if you've got a lot of drill holes to fill. It's easy to get a bit lax in attention.
Yes, exactly. So when you are installing a chemical DPC, the standard sort of method is to do 120mm centres, and then doing it on the up ends and down ends along the mortar line. So always do it in the mortar, not into the bricks. If you're in a situation where you have a stone wall which doesn't have a sort of a regular mortar line, then what you do is you try and drill the holes in such a way that you have a sort of uniform line if you can. So once you've installed your DPC for rising damp, the next step is replastering. So why is replastering necessary? If you do have a situation where there has been rising damp, over time salts will accumulate in not only the wall but also the plaster, and so the plaster will become contaminated, and which is where you'll get these hygroscopic salts creating damp. So it's recommended to remove this plaster, which should hopefully take away this contaminated plaster and should then be replaced with a replacement plaster. So there are a few different replastering methods. One way is, first thing you need to do, like I say, is hacking off. So you need to remove the salt contaminated plaster. The recommendations is for at least 1 meter above DPC or 300 millimeters above the highest level at which dampness is detectable. So that is also in the British Standard into rising damp as well. So there's the first way is the traditional replastering systems. So this is using sand and cement. So you would mix this up on site, 3 parts graded washed sharp sand, 1 part cement with a render additive added to the plaster mix. So you can see in that diagram it will be in combination with a DPC there, such as dry rod or dry zone. You would also install a liquid applied DPM as a bridging compound, so that would prevent any bridging. And then followed by your skim coat and then a mold resistant emulsion paint to prevent any sort of mold growth. So yes, like you say, you would add a render additive such as a Render Guard Gold, which acts as a plasticizer and waterproofer and salt retardant. It's key to use sharp washed sand and make sure the sand has no contaminants in there, otherwise you might get callbacks of salts. The only issue with this method now is that it can't be used in most sort of heritage projects as the rejection of cement, and also by using 3:1 sand cement you do create a cold dense surface, so that can create a risk for condensation.
Incidentally, Leighton Buzzard is a good type of sand if you are going to do this more traditional method.
So just saying earlier, when you are dealing with sort of damp floors or putting a DPC and replastering, one of the things you need to do is apply a liquid applied DPM, so a damp proof membrane onto the floor, and you can also apply it up to the DPC level on the internal wall to prevent any bridging into the new plaster that you put in. So now the sort of new modern way for plastering is a renovation plaster. So these plasters are lightweight, so they can be hacked off quite easily if they need to be removed, so they don't damage the underlying brickwork. They are breathable, and they can be water and salt resistant. So in the same way you would apply it in combination with your DPC and DPM, and effectively these overcome the problems of sourcing any sort of washed sand. You don't get any inconsistent mixing because it's already done for you. All you do need to do is just add water, and they create a much less dense plaster mix. So they also make the wall feel warmer, as they have sort of insulating properties, and also they control the dampness usually with hydrophobic additives, which allow the walls to stay to dry out and also prevent any other moisture reaching the surface. So they're really sort of useful method now, and highly recommended for as a replastering method. But if you're in a situation where you can't use wet plaster, you can also use express replastering as well. So this is plasterboard system. But the key aspect you need to look out for when doing this is the adhesive you're using. So if you use a sort of gypsum based one, quite commonly they don't have much moisture resistance, and so at Safeguard we'd recommend using dry grip adhesive in combination with a primer cream called Dry Shield. So you can see in this diagram here, you'd install your DPC of dry rod or dry zone, you'd apply dry base liquid applied DPM, and then you would adhere your plasterboard with dry grip, and then you'd skim onto that and then apply a mold resistant paint on there. So it's a nice plasterboard system. So there's a salt retardant primer, so that's the Dry Shield cream, which sort of reduces the salts coming to the surface behind the plasterboard, and you'd use a moisture and salt resistant adhesive or dry grip, and this is a great breathable system, which has also been BBA approved as a way of replastering in a rising damp situation. So it's great for any commercial tenanted properties where you need a quick turnaround, where you need to be in and out within a day or two. And then where you are in a situation where you want to use a physical membrane, one of the methods it can be used is dry base flex. So this is a two-part system of a polymer cement adhesive, which adheres onto a fleece membrane, which has a polypropylene layer within it, and this fleece can then be plastered onto. So it's a great method for any sort of like chimney breasts that have got hygroscopic salts, or any areas where you can't solve the damp issue because there's some form of penetrating damp and you don't know what to do. So you think, okay, I'll put this on. So this should be used floor to ceiling. In combination with a DPC as well. So this is a great sort of low profile method. So you would apply your cement based adhesive onto the wall, which then allows you to offer up the membrane, and then this will accept plaster finishes directly. So there's no need for plugs or any sort of unnecessary penetration of the membrane. So like I say earlier, you'd simply apply the adhesive. You then offer up the membrane, let that sort of set overnight, and then the next day you would then apply a finishing coat of sort of Egyptian hardwall, followed by a skim finish. Okay, well that's just about it for the this sort of general overview of dampness. So we've just gone through, like say, condensation, penetrating damp, and rising damp. If you have any immediate questions that you want to ask us, you can submit those by the webinar submission form below. If you have any sort of very detailed questions that you want to ask us, these can be sent to webinar@safeguardeurope.com or info@safeguardeurope.com. And like I say, if you have any other feedback that you want to give to us, you can simply give that to us via the email address above. Whether it's good or bad, we want to hear it. Okay.
Lovely. Thank you very much, Michael. Cheers. I think that's the end of the presentation now, and look forward to any questions you guys might have. Thank you much. Goodbye.